Um, Hello, everyone. I'm hoping I'm live. It's really hard to get any sort of visual feedback in this virtual world. But my name is Kevin Galligan. Welcome to the talk, Kotlin Multiplatform Production Considerations. I'm a partner in a company called TouchLab, and I've been coding for a couple decades now, doing Android since before there were phones, and a Kotlin GDE. Oh, I'm now hearing myself. Okay, I had to mute myself because I was getting myself back. Okay, great. Uh, hold on a second. Wait, I got it. That's going to kill me. Oh, man. Okay, live. We're doing awesome, fun stuff. I was getting the live feed through a browser in the background. Okay, great. We're going to start over again. Hi, welcome to Kotlin Multiplatform Production Considerations. I'm Kevin Galligan, a company called TouchLab. We've been around for about a decade. We decided to do basically Kotlin Multiplatform almost entirely in the recent past, and we're super enjoying it. We are happy to have some awesome partners out of the gate. Specifically, Square's been great in helping us to do a bunch of open source stuff, and we've been helping them with a bunch of stuff they're doing with KMP, and it's been pretty cool. So, Kotlin multi-platform production considerations. So a little behind the scenes, if you haven't spoken at a conference before, you kind of submit topics well in advance, and I've been sort of knee deep and kind of helping companies bring Kotlin multi-platform to production in like a more scaled fashion. So I kind of in my mind had what I what I thought I was going to talk about, and then it kind of turned into a bunch of like separate topics that you might run into when you're doing multi-platform in production. And I watched this morning or earlier today, we had John O'Reilly and Roberto and Russell Wolf from TouchLab all give like great talks, which covered a lot of the intro territory that I briefly covered. So I'm going to like whip right through that, and then we'll stick a little more on the production level topics and then leave some time at the end for questions, because I'm always kind of surprised at what people ask or what they're concerned about. So that's what we're going to do. So let's dive into it. So what is KMP and KMM? Very quick intro. KMP is Kotlin Multiplatform. I'm kind of assuming you know that if you're here, but what is that? That is essentially, it's a way to share Kotlin code across many different platforms, right? And the top level, high level, it's JavaScript, JVM, and native. There's going to be a separate compiler for WebAssembly at some point in the near future. Well, I don't know when, but hopefully near future. And the idea is you can have some like platform agnostic common Kotlin, and then integrate some specific platform code in Kotlin as well, and produce cool stuff. And why is this different than everything else? It is really, to me, about the quality of the interop with the native platform. It is this, it's a hard thing to do well, like, with Java, and you want to talk to C and C++, it's J and I have experience with that. It's not super great. With React Native, like there's some weird bridge stuff you got to do. With Flutter as channels, it's kind of like all these things treat the native platform as sort of this hands-off other thing, and Kotlin is trying to make the interop, really solid. So this diagram gets pretty complex though as you start to get into it. Like there's a lot of downstream targets, and I don't know, there's a lot going on, right? So it's complicated to explain, especially when you're new, how to configure all these things and what they all mean. So along a few months ago, not even that long ago, comes KMM, which is just specifically multi-platform mobile, right? And JetBrains has made a special focus just on native mobile code sharing, which is kind of, as Russell said, it's the killer app, and it's really what we do because we're a mobile shop. So it is not different though. Like that's the one thing you need to understand. It is just a branding designation. It's still KMP under the hood, and all the Gradle stuff underneath it uses the same stuff, right? Dedicated website, of course, helps you get started. Dedicated docs, and the Android Studio plugin that's built just for mobile. You can still use it for other things. We'll talk about that briefly a little later. So why these technologies? And I think this is important Because besides just the fact that you can do it, why is this different, and why should you focus on it, right? And I've been since 2015 kind of on this weird journey of sharing essentially Android code to iOS, starting with J2OBJC and then transitioning to KMP a few years ago. So I've thought about like why quite a bit, and this is sort of the condensed thing that I come up with, which is it's like an optional natively integrated open source code sharing platform based on popular modern language Kotlin, and facilitates non-UI logic availability on many platforms, right? And there's a lot to unpack there, which we're not going to do all of it. I've a bunch of other talks you can see. Also, a critical thing is JetBrains, and without a major funded organization that's building the tooling and the language, I think it would be very difficult to pull this off. And you can find plenty of examples where other groups have tried and haven't really been that successful. So when people are like, why not Swift for Android? I'm like, well, Apple's not going to care. And nobody's building like, Swift with bytecode, Java bytecode output. Like it's just a totally different thing. So JetBrains is kind of the differentiator in the middle. So it's shared native code, not cross-platform. I found over time, and I feel like the recent political trauma we all went through is a good example of sometimes you should stop using certain phrases, and cross-platform is definitely one of them. So it's not cross-platform; it's shared native code, and it's kind of a different thing, right? And especially like Android itself is Kotlin. So if you look at all the other options that are out there, it's some kind of third language. This is a unique situation where the Android side is actually not foreign at all. It's the thing you would normally use. iOS uses Objective-C interface. It's not everyone's favorite thing, but it's certainly a lot more native than many other options like Rust or whatever you're going to use. So not necessarily UI. This I think is important to keep in mind the necessarily. So we'll talk a little later, and it's been mentioned that JetBrains released the desktop Compose, and I think it would be unrealistic to think that there won't be a Compose for iOS at some point. How good is that going to be? I don't know. How much are you going to use it? I don't know, but it doesn't matter because you don't have to. That's like the whole point. It's optional sharing. You can choose what you want to use. And low risk. So integrating with an existing application, integrating with an existing team, because it's optional sharing and the interop is like one of the primary design goals. It like integrating with existing stuff is low risk versus a lot of other options, and that's something that orgs are definitely going to think about. So, production. So who is shipping? And Square, obviously, we're working with them, and there's a bunch of other folks, PlanGrid, Kareem. There's a list there. It's one of those things that it's hard to know because it's not like you can tell unless they write a blog post about it. You won't know that it's in there. So I've been, as Russell was saying about libraries, like earlier on, you can name all of them because there are only a handful, and now it's different. And same thing with like who's in production with Kotlin Multiplatform. There's many more that I don't know about at this point, and you kind of get surprised when you hear that somebody's doing it. So there's also this interesting thing I point out is this company called mParticle is shipping a library generator that generates shared Kotlin, which is then compiled down to whatever you want, and essentially it's for typed analytics, which is something that it's one of the examples of things if you're looking for something to do, I would suggest doing because nobody really likes doing analytics if you're a mobile developer. So and we're doing something that's going to be in production very soon. I can't tell you much about it, especially because it's one of those things that people are, I don't know, it's a very sensitive topic, but we're building a COVID-related app, and that's coming along very quickly, and it's actually turned into what I'm doing mostly with my time. So, and the announcement that came out recently, if anybody missed it, was Netflix is shipping shared Kotlin code inside one of their apps. It's not the app that you have unless you make movies, but it is the app that they give out sort of quasi-internal, but it's people making stuff. Anyway, the importance of this, I think, is I want to highlight, which is, if you heard Google was putting a little bit of KMP in something, you'd say, yeah, well, Google, they're kind of invested in Kotlin. One of the other big tech companies doing this. It kind of says something about the state of where it's at and what's going to happen in the future. So take a look at that. It's really interesting. Russell touched on this. I said we're going to cross a lot of the same content. Is KMP production ready? And people phrase it like a binary, or they point out the terms like it was experimental and now it's alpha. And it's like, look, terms are kind of whatever. To me, it's, we were shipping stuff in 2018 in production. It's more like, is it ready enough for you? Are you ready for it? I should redo that slide. That sounds cheesy. But it's early adopter for sure. And if that's not where you want to be, it's like definitely, you might want to give it a little bit of time, but it's also a great time to get involved, especially if you're interested in the open source world or having some sort of an impact on library development and that kind of thing, because there's still plenty of space to have an impact. So getting started very, very briefly, the Kotlin Multiplatform mobile doc site has really improved the documentation considerably, and actually various folks in the community, us included, contributed docs to the official site, which I think helps because going back, a year or so, that's why we built CampKit, as Russell mentioned. Like if you went and Googled getting started with Flutter, you would find something that 5 minutes later you would have a running Flutter app. And same thing with React Native. It was just like, do this, do that, do that. Boom, there you go. With Kotlin Multiplatform, it was like, if you found something that was up to date, which was a big if, 3 hours later, you'd still be trying to figure out your Gradle setup. So CampKit is trying to be that, maybe not 5 minutes, but at least 10 to 15 where you can start and get something running. So it is kind of mostly what we use in production now as far as libraries. A little bit architecturally, although that is definitely a moving target. But check it out. It's we're maintaining it and updating it. Even today, I had to approve some PRs from Russell. So, okay, cool. Production, I thought you said production. This seems very intro, and you'd be right. But now we're going to leave the intro part and get to a little more of the detail. So, tooling, and tooling is actually kind of where I'm spending a lot of my time. Not necessarily on, IntelliJ. I'm not working on those things, but I would say right now, Android developers, I would assume by and large use Android Studio. If you're going to go knee deep into Kotlin Multiplatform, I still kind of suggest you should get comfortable with IntelliJ. The Kotlin plugin tends to be the most up to date on IntelliJ and tends to be, I won't say the most compatible. It's just that the bugs get fixed there sort of first and then make their way to Android Studio. Having said that, I spend now day to day in Android Studio because of that project I was talking about. Like, we talk about it later in the talk, but we're hiring. So if anybody's interested in working on multi-platform stuff, like I'm now back on working on client stuff because we need more people. But anyway, I'm in Android Studio day to day, and it's gotten a lot better. I'd say go back like a year ago, I wouldn't even consider trying to do multi-platform in Android Studio. But and there's nothing wrong with Android Studio. It's just that IntelliJ always had a newer version. But now the Kotlin Multiplatform mobile plugin is kind of, I think it's going to help to ensure that at least, Kotlin stays up to date. The Kotlin plugin stays up to date inside of Android Studio. But yeah, so one thing is you can run and you can debug code from the Android Studio multi-platform plugin. But I would say debugging in general right now is not. This is like so this is about production, but it's sort of a good news, bad news talk. So the situation for like live debugging is a little bit tricky. So the Android Studio plugin is kind of, it technically can like stop at breakpoints, but that definitely needs work. I'm like kind of going back and forth with them. We've been sort of going back and forth with JetBrains for a while because we have this thing called the Xcode plugin, which allows you to run and debug Kotlin code in Xcode. And there's sort of this like LLDB formatting script that's part of the Kotlin native thing, and we've been sort of optimizing it for visual use. It's kind of designed for the command line use. Unfortunately, Android Studio, app code, IntelliJ, they all kind of use the same file as does the Xcode plugin, but it's like not built for a visual thing. So it's not great. It does work in the Xcode plugin, but especially around like functional callbacks, suspend stuff, it's still like a little rough around the edges. So just FYI. Yeah. So sometimes I talk ahead of my slides, and then I get to the slide where I should have given all that information. So LLDB experience needs more work, but they're working on it. So crash reporting, you will definitely need to have this involved in what you're doing. So if you're coming from the Java world, the whole exception, everything is an exception thing is not like a thing in the iOS world. So if you just set up crash reporting and you don't do anything special, this is the kind of report you'll get from your Kotlin code. They'll all look exactly like that, which doesn't tell you much about what happened. So using some of the stuff that's in the native runtime and sort of integrating with Crashlytics and Bugsnag currently, like you can get symbolicated reports. So go check this out. Future stuff, which I don't know when we'll get to, they both leverage sending off like handled reports. So you'll kind of get like the crash, and then the handled report as separate things. We want to try to like integrate them. So it's not perfect, but it definitely works. And we're sort of going to have to figure out other clients like New Relic soon, which I'm not really looking forward to, but it is what it is. So package managers. This is where things get tricky. And Russell kind of started talking about this. Out of the gate, there's like CocoaPods integration, but it's set up that you have to build locally. And some people are kind of building their own like roll your own fat framework, and some people I've seen do a little bit Swift package manager. Carthage, although earmuffs if you're a Carthage fan, but I feel like that's going to go away. It's going to be kind of CocoaPods and Swift package manager in the future, but we'll see. Anyway, this is one of those things that's going to get a lot of attention in the future. We'll talk about it in a little bit. And if you're really interested, we're kind of looking for folks to talk to, but it's a later thing. But it's definitely like not a well-solved portion of the thing. So it's part of that early adopter stuff. And even more so, I think, in the JavaScript realm, which we admittedly haven't done a ton with. But there is some amount of support now for like consuming NPM. Some folks are having, like, they have Gradle plugins that push stuff. There is some TypeScript support, but I've been told it's like, still in flux, but it's definitely a major focus of JetBrains' future plans. So keep an eye on it. We're hopefully going to have a lot more info around that soon. It's just not the first thing a native mobile company tends to do, but I think it's going to be a big deal going forward. There was, the desktop compose. I'm definitely talking way out of order on slides here, but the desktop compose announcement is interesting, but also like along with the same announcements, JetBrains is hiring people to work on the web compose. So I think that JetBrains is definitely focusing on this, and I'm just sort of reading the tea leaves, but that there's a fair number of folks interested in using Kotlin for JavaScript, which is, if I had to place bets, I wouldn't have necessarily guessed because TypeScript's it's okay, but it seems like it's something that is going to be a big deal, and they're certainly investing in it. I think it'll be really interesting if WebAssembly matures, because then the compose situation and Kotlin is like really well built for that kind of runtime. So we'll see. Anyway, integrating. Before you can code level integrate, you kind of have to like sell it. You know what I mean? So I will preface this with like, if you're an Android developer and you show up at a meeting and you're like, hey, check out this awesome thing, you may not get all thumbs up. But I've heard from people a lot that aren't necessarily excited about Kotlin as a shared language that quote unquote iOS devs would never like go for that, right? And my response is kind of like, you have to take a step back and realize we're all we kind of process information in similar ways. We kind of tell people like, start with empathy, right? Like, imagine if the JavaScript developers burst into the room in one of your planning meetings and was like, hey, we don't got to do native anymore because there's React Native. We can all use JavaScript. there is like a knee-jerk reaction to, to that kind of thing. So it's just understanding that people get a little defensive about their platform at times. Um, Best thing to do really is like, people have a range of reactions. So if you have a team of people you're talking to, a team of iOS folks, um, I would say look for people who are curious about the tech. And you're going to need allies, right? Because like um, one of the issues we found, somebody was doing a hack week. One of the reasons CampKit exists is because they were doing a hack week, and it took like they were trying to integrate some shared Kotlin into their production app. And I don't know if you've ever seen a production configuration for any platform ever. Um, they're complicated, right? And iOS is certainly no different. So you know, it's like imagine if an iOS developer who hasn't done much with Android came in and tried to like modify your production build system of a mature, Android app or the web or whatever. You really are going to need help, especially in the iOS world. It's kind of a different thing. So, but the good thing is you can just kind of like integrate like a small, handful of things. You don't have to do like a whole different thing. I'm definitely out of order on slides here. I was about to make another point, which I'm going to wait till later. But anyway, it is important to also remember the differences, right? Like they're not all cross-platform solutions. So if you get into like a shootout between, React and Flutter and KMP and like, phone gap, um, I kind of try to keep it out of that realm. But if you're going to get into that debate, um, the easiest one is it integrates with the native stuff, so you can still use Swift UI, even if you're using KMP, that kind of thing. Uh, anyway, it's important to just kind of understand what these things are different. Yeah, here's the out of order thing. Pick something that nobody on the team really likes. So, and then implement that in shared code and see if everyone thinks that that's not terrible. So a good example is like, I don't know too many iOS developers that really love core data. I'm sure they exist, but doing, database stuff, especially with SQLite, it's a great database library. The end particle thing is also a good example, and this is coming up a fair bit when we talk to folks. Analytics is one of those things that's hard to get precise because it's usually just like a map of strings. So creating typed analytics libraries and then sharing them between the teams kind of gives something that you can do to manage that. And the developers, it's like one of those things that is hard to get precisely right and gives you like no joy as a developer because you don't see anything fun visually. It's all for the marketing people. So it's a good place to do it. So anyway, we have some links on selling KMP. Cool. So what about actually integrating? This is what I thought the talk was going to be entirely about. But then working with like multiple clients, I thought we would kind of converge on like the answer for everybody, and that's just not how it went. So this is ultimately what you want to get to sort of logically, right? You've got your Android specific stuff and your iOS specific stuff, then your shared code, and everything works together great. And everyone loves it, thumbs up. But where the code lives and how that actually gets into the various pieces is kind of a different story. So in a Greenfield app, and Greenfield app is kind of like how the CocoaPods integration currently is set up out of the box. It's kind of how all the samples are. They're very small and don't involve a lot of moving parts, right? And they don't involve large teams. So you can just kind of build that. This is the simplest thing. And it's not too hard to do, but it's probably not going to work in a larger team or where you're trying to modularize stuff, right? So this is kind of where I've been living for the last, I don't know, not a couple of months, but on and off quite a bit. So shipping a binary is, it's kind of the least disruptive thing for a team. So, you have this shared code in Android, you carve out some code from Android that you're going to share off into a CocoaPods thing, and then the iOS team can just pull it in and use it, and that looks like every other library they use. They don't know much that it's Kotlin. They don't have to learn Kotlin. They don't have to install the JVM and all that kind of stuff. Downside is you don't really, you can't really debug that, and you can't really open it because you don't have the source. And we designed like the Kotlin Xcode plugin as sort of a soft like read mostly leader for the iOS developers into doing Kotlin development. So if you have the source right there, if you can step into it and see it and debug it, it kind of is a good way to get started as opposed to like having to jump in and learn everything from scratch. If you have this sort of shared separate binary, you kind of can't do that. So while it's doable, it's not ideal. So we've been kind of doing this model. We're sort of getting into that where you kind of ship a shared, this binary, and the iOS team can just digest that. But then there's sort of the like, follow these directions, flip a switch, and then you can like build locally and then debug and test it and be involved in the development of those things. This is ongoing. We're trying to figure out this good configuration and still working on it with, the client folk. Somewhere in here, I have a call out. Oh yeah, I should have put this before that. We're maybe building like a new tool. It's something along the lines of like, can we point it at a GitHub repo and then like it'll automatically do some kind of CI to publish a library you can use inside your iOS stuff and possibly also debug, like making the source available. And not just for CocoaPods. We've been sort of experimenting with like XC frameworks and Swift package manager, all this stuff, but it's kind of it is like a big topic. Every team's kind of different. And so it'd be interesting if you are actually shooting to get stuff into production and you're having trouble, please reach out because we'd like to talk about what we're sort of trying to figure out how to build. And then also if you are getting started and you're having trouble, we are a consulting company. So that's the ad for TouchLab. Reach out. This is what we do. But anyway, so this is the grab bag of assorted pieces of information section of the talk. So Russell mentioned concurrency. This is kind of what I've talked about for the last 2 years, basically. The concurrency model of Kotlin native. It is different, but it is also changing. So for the very basic summary, there are 2 rules. One thread is equal to mutable state, so you can do whatever you want, normal state in one thread. And if you have many threads with the same state, it's immutable, right? It's frozen. So there's a lot more to that, but that for a simple reminder is what the rules are. And that is changing. And JetBrains kind of posted a timeline for when we should see a preview. So they're saying by March. I would be surprised if there was a preview by March. And then you got to bear in mind, how long does it take for that preview is considered to be, production ready, not to use the binary. And then what about coroutines as a library? It took a long time for multi-threaded coroutines in the current memory model, that kind of stuff. So I think realistically, something to use second half of next year, like hopefully. So, we'll see how it goes. But I will say, and this is true, if your code is not really doing like library level stuff, you really don't have to change much. The only thing that's going to happen is a relaxing of the rules. We don't know what they're going to change it to, but anything they do or anything they've even like talked about is a relaxing of the current rules, if not like a fully just shared state model, which philosophically I wouldn't be excited about, but I get it. So it's weird. I mean, Stockholm syndrome maybe, but I've kind of enjoyed the idea of a safer concurrency model. So we'll see. And Swift just published something that's attempting to also have some kind of new rules around safety. I don't know. Yada yada. You won't have to change your code much unless you did things like write concurrency libraries that were based around that model, which we did. So we're going to have to change a number of things. Anyway, concurrency links, intro, thoughts on changes, deep dive, all that kind of stuff. But the short version is, if you're going to use Kotlin Multiplatform anytime before late 2021, and even then, I'm not sure, you're definitely going to have to understand it. So, but it's not that bad. I promise. Kotlin X coroutines. Russell kind of talked on this, so I'm not going to talk about it much. There were single-threaded coroutines for native, and now there's multi-threaded coroutines, which at some point in the near future should be the main library. It's kind of a weird situation, but I don't know, just reach out in the Slack if you're confused. I'll help explain it. But it's going to be not a weird situation soon. And KTOR, I have a deep dive that I'm not even going to talk about now, but you can read about the saga. Anyway, simple answer, 142 plus, it's, just use the multi-threaded coroutines. Cool. So this is more important. As you are discussing with your team or whatever, like, hey, we're going to use this, there is this one thing that they're very much not going to like, which is a single Xcode framework. So when you export Kotlin to an Xcode framework, you you basically can have one framework, and it's a long explanation as to why you can only have one framework. And I won't really get into it, but the whole point is that if you can have multiple modules, but if you want to use them all, you have to make one framework out of it. You can have multiple Kotlin frameworks in the same application. They just can't talk to each other. They're at a binary level. Everything in them is totally different, right? Like the SQL classes are binary, not compatible. They have different names. They don't know about each other. So if you had, 10 modules and you had 10 frameworks, like, okay, but they can't talk to each other, which is a major limitation. So there are some issues in the Kotlin world that they're going to look at that. But I would say, who knows when if they're ever going to figure that out. And largely it's around because the compiler takes everything it knows about and only includes the binary that it absolutely needs. But if you have multiple things, the one compiler doesn't know what the other ones are going to need, so it can't produce that in a reliable way. Which is why if you go back a few years ago, if you were using Swift, you had to include the runtime, which would add 20 megs out of the gate. And Kotlin would not be able to be competitive if they did that. So you don't have it. So anyway, this is kind of what everyone wants, yada, yada. You can kind of, if you're going to have multiple frameworks, you can kind of do let's say all of your things in one thing, and then your analytics could be in another thing, but whatever. Anyway, it is a limitation. It does kind of suck. There are some workarounds, but essentially you have to use one framework for the near future. Check out some more information. Kevin from our team, the other Kevin, did a blog post about this. And then there are issues that are going to try to fix this. Go like them and make noise. The JetBrains team definitely listens. So binary size. And this is a big question I get quite a bit. So I keep saying there's a blog post coming. It's been coming for about 6 months, and eventually we'll get it. Just a lot of data and variables. In the iOS world, to get a real sense of how big something's going to be, you soft publish it to the App Store, and then it tells you estimates. And you get two numbers. You get download and disk size. And if you just have a couple of functions with no libraries, it's about 150K download and 500K disk size. That's a delta. It's a difference between no Kotlin and adding some Kotlin in the same app. That's what you call bare minimum. We took CampKit and we stripped out all the other stuff, and we just did the same process on it. And adding CampKit and its libraries adds 1 mega download, 4 megs of disk space. And then that's largely based because there's a bunch of libraries in it. And then your code after that is just going to incrementally grow. We did a thing where we generated classes that were roughly equivalent. It's very simplistic, but it was measuring the difference between Kotlin binary size increase, going from 0 classes to 100, all the way up to 500. That's on the x-axis, and then the y-axis is size. And after the overhead you pay for just having Kotlin in there at all, you get a linear increase or a linear-ish increase. Now, all these, which is to say, if somebody's like, how much does Kotlin add? It says, well, roughly about as much as your Swift code's going to add. So it's not bad. This is the chart we first got. And we started doing this because people reached out and they're like, hey, we were doing tests and the numbers are terrible. And it was like, wow, this is really, really aggressive, really, really bad. Again, it's a longer blog post, but essentially what's going on, and it took us a little while to figure it out. Here's a Kotlin and Swift class. When you compile them to a framework on Xcode, you get this Objective-C add-on adapter so Swift can talk to it, right? And then if you have a whole bunch of classes and they're all public, it looks like this. And that's why you get this big difference here. So if you like mark these all as internal, or at least if you only make the ones you're going to use external, then you get a much smaller binary increase. So it's like, a little piece of, if you're going to add a ton of Kotlin in there, try to make it not all visible to the iOS side. It's like just some practical piece of advice. And then it's not so bad. But like that adapter turned out, as far as we can tell, it's pretty huge. One of the reasons we don't have another blog post is because I want to do like a ton more tests just to understand exactly what's going on and what the impact's going to be. And we just like haven't found time to do that. But yada, yada, it's not so bad. Anyway, here's some various techniques to like get around that. You can kind of write like, I don't know. Wait for the blog post, who cares, or to reach out. So the TLDR, if somebody's like, how much is this going to add? Like, tell them that. And then, in the iOS world, that's like not terrible. And if you cut out some libraries, it'll be smaller. So you can kind of play with the numbers. But anyway, direct Swift interop, maybe 2021. I don't know if that's going to happen, but they are talking about it quite a bit. And now there's ABI stability. I think it'll be on the roadmap. It's not necessarily going to solve all the problems. You're not going to get all the Swift features. You'll just get a direct way to talk to them. It might solve the size problem, but I don't think it's going to solve a bunch of other things like generics. They're less flexible if you're doing actual Swift than if you're talking to Objective-C. That's a long story. Things like that. So it's not necessarily going to solve all the problems. You won't get structs. You won't get stuff like that. So anyway, yeah. So, and it's still early adopter-ish. So it's alpha, and not everyone's really excited about alpha, but it is what it is. So what's coming in 2021? As mentioned, Compose for desktop. That was a pretty big deal. And kind of a surprise, but it was pretty cool. And then, as obviously mentioned, they're hiring for web. I would be shocked if, there wasn't an iOS version of Compose, but I imagine it's going to be after the concurrency model changes and, Compose is more stable, that kind of stuff. But it's still pretty cool, and it's coming down the road. And I just get out in front of this because every time I give this talk, inevitably one of the questions is like, well, why not Flutter? What about Flutter? Yada, yada, yada. I don't really compare them. They're very different tech. Kotlin's about sharing code. Flutter is a portable UI. Yes, adding Compose to all these layers does feel like they're kind of going to be encroaching on the same territory, but there's a bunch of time. I think, Flutter's really interesting, great tech. It's not a zero-sum game. It's not like any team's going to pick one or the other, so I wouldn't worry about it that much. But yeah, that's kind of my answer, just in case someone's going to ask the question. Anyway, and it's coming down the pike, which we're going to be focused on the more stable compiler plugins, which is going to be huge because there's no like annotation processing. Yada, yada, yada. Proper WASM, I think, is a really big deal if they figure out a garbage collection inside of WebAssembly, because then Kotlin and WebAssembly are much closer in model to Kotlin and JVM, and it's going to be a really interesting future, especially if Compose is added into that and that kind of stuff. So check out the Kotlin community Slack. I would say that's the most critical piece of information you should probably get from this talk if you got nothing else, and because people are happy to help in there, and you can talk to JetBrains directly. And that's it. That's kind of my talk. There's my information. And remember, we are definitely in the process of hiring folks who are interested in the tech, who are mobile development experienced. That's it. So we got some questions. I don't know how much time I got. How do you seamlessly import shared library into Xcode while doing active development instead of building the pod file and installing via CocoaPods manually? I don't understand that question. If the question is, how do you seamlessly import? I don't know. I don't know the question. Probably does fall under the category of like, that's not a solved problem right now. Like we're working on that. Like we've built for a client a thing that will build your Kotlin to a binary and then deploy that as something CocoaPods can import like other binaries. So it doesn't have to compile. You don't have to install the JVM and all that kind of stuff. And there's work going towards Swift Package Manager. But again, I would say this is more of a reach out. I don't know if we're going to I'm still waiting to see what JetBrains is doing with their new CocoaPods work, but it's all around local builds, and I don't think that that's very seamless, especially for larger teams. So, how's KMM getting up to date with iOS ecosystem? Um, do you mean what is their history of keeping up with new releases? I think that's what you mean. So, I would say good. They are facilitated by the fact that um, it's mostly in the not UI space. So, um, and mostly in like the architectural layer of libraries, which still have to generally maintain Objective-C compatibility. So if it was a Swift-only library from Apple, that would be a problem. But other than that, because you're doing the hardcore platform native stuff is generally in platform-specific code anyway. Um, it's not the same situation like a Xamarin or a React Native where it's like, oh shit, there's a new release, we got to wrap everything. Like it doesn't work like that. So it's kind of a less they do keep up to date. I mean, like anytime there's a new release, anytime there's an issue with the build, tool chains, that kind of stuff, they fix it right away. But it's less problematic than I would think some of these other ecosystems because it doesn't need to, like, they don't need to worry about Swift UI, right? It's not part of what they're worrying about. There was an issue recently that was like required a release of Kotlin, I think, because of the Mac OS and whatever that thing, the compatibility thing that allows you to run iOS on Mac OS. But they fixed it pretty quick. So this is again important why you need a funded, self-funded company, large company that's going to be behind this. Like if it's all volunteers, it kind of gets weird, right? So good. Besides memory model shenanigans, what in your opinion is the biggest issue solving KP? Tooling, the integration, the debugging, all that kind of stuff. I think there's enough that's already problematic. If you're trying to sell this to, let's say, an iOS developer, you're like, here, try this thing out. Oh, that doesn't work. You got to, clean this out and right click that and put some duct tape there, and that doesn't work. And yeah, that build takes a long time, and you can't use that. You got to use this tool. You can't debug it. Like all that shit adds up pretty quick. So they're definitely working on that, but it's going to be a while. And the philosophical accepting of the fact that Kotlin isn't Swift. Kotlin looks like Swift. They're not the same. So there's an accepting of compromise that needs to be upfront. Like, and if you can't get past that, it's going to be real difficult. So I think I would say those things, and then everything else is like people stuff, and there's a lot of people stuff out there. So we'll see how it goes. Where if anything changes on the iOS side that could be detrimental to KMM, as in like something Apple decides to do, I would say I don't think these organizations look at the stuff the same way that people might, because I feel like people are sort of emotional about their platforms in a way that like Apple doesn't gain anything by preventing other technologies from running on their platform. They only gain something if the technology's shitty, right? Like if it's producing a bad experience on their platform, if it's insecure. I saw someone today said they finally uninstalled the Flash player on their machine, and I'm like, what? I haven't had Flash on my machine. I don't remember the last time, and that was killed by Apple because it sucked. You know what I mean? So like they're going to take out stuff that sucks, but like, KMM produces it's LLVM toolchain, and it produces the same kind of binary. So it would be like, what if Apple decided C++ and Rust were something they didn't want? They're the same kind of risks. That would be my answer to that. I can't see anything obvious. Are we bound to using KTOR? Can we use retrofit? Okay, San Francisco delay. You cannot. You don't have to use KTOR. I tell people a lot, like, if you think about an app, right? Like if you're using a networking library, what you use in your app is probably 4% of the entire library, right? Like you're going to use a get call and a post, and that's it. So you can very easily decide you're not going to use KTOR and just write an expect actual, and then implement that on the native platforms. That's pretty straightforward. SQLite is a different story, because I know people who've like used Room on the Android side and used Core Data on the iOS side. But if you think about that, like you have to, it's a lot of work you have to do there in SQLite. Unless you hate SQLite's actually like a really good library. I would only use, like, I would choose SQLite over Room. No offense, earmuffs, Android people. But I've also talked to the Android Room team, like, hey, let me know when you're going to get this into Kotlin, and we'll get that working because it would be cool. Have you run into any issues where XQt 12 requires more architectures? No. I also just got a new laptop. I did not get the ARM laptop, so I imagine that would suck. I haven't come into an issue with XQt 12 yet. XQt 12 doesn't require architectures other than what your computer is, because it's a simulator, I think. The answer is no, but I also haven't tried to do everything, so maybe I'm missing something. Help bridge the gap between iOS devs and Kotlin acceptance besides core data. Other annoying things on iOS that KMP libraries should solve. That's a good question. I think if you're doing a lot of your architecture inside of Kotlin, like some people just do, a data module and they're not doing any of the architecture inside Kotlin. But, we're doing more greenfield apps, in the TouchLab world. And you can do all your architecture in there, so you can run everything inside coroutines, like inside your shared code, which is kind of neat. Other than that, I don't know. I mean, like, the core data is kind of a big one. Trying to think of what other places are things that people don't like. If you're okay with KTOR, then also running your networking code and your serialization code can be a good one. I talked to one team who used serialization in Kotlin. Their iOS developers started trying it out because it was performing better than what they had in Swift, which seemed really odd, but they were using something, I don't know, weird. That might be useful. I don't know. It's shared logic. I'm trying to think of some good things to do. There's always stuff on a project that no one really digs. Yeah, I don't know. I have to think about that question. I don't know off the top of my head. All right. I think that's it. All right. Well, everybody, there's no clapping. There's usually clapping at a live event, so, or not, but anyway, cool. It's been great.